Hello everyone, this is Samiran Methi, Senior Lecturer in Computer Engineering Department from Praveen Patil Polytechnic. I welcome you all for the session on Data Communication and Computer Network. I hope you guys have watched through chapter number 1. Now proceeding with chapter number 2. The title for the same is Transmission Media and Switching. So once the chapter gets over, the learners will be able to understand what is communication medium with its types and what is the basic difference between guided and unguided media. So firstly, talking about communication medium. So a communication medium is also known as transmission medium, which is a communication signal which is carried from one computer system to another. For example, if we need to connect two computers, so there must be some medium through which we can pass our data. So that is nothing but communication medium is all about. Now why there is a need of communication medium? Obviously without transmission medium we cannot effectively communicate with two devices. Communication media is a middle part of sender and receiver obviously, and it is needed for faster communication. Now, which are the criteria for selecting transmission medium? Firstly, attenuation should be low. Now, what do you mean by attenuation? Attenuation refers to loss of energy as signal propagates from one host to another host or from one device to another device. So, attenuation is nothing but loss of energy. So, obviously, we as a sender or a receiver will like to make sure that loss of energy is as minimum as possible. So attenuation should be low while selecting a transmission medium, and the amount of energy lost depends on its frequency. Next is number of users. It is the concurrent number of users, concurrent in the sense simultaneous number of users supported by the communication medium. Obviously we will select that particular number of that particular communication medium where it could support large number of users at a single instance, at a single moment of time, right? And obviously cost is also one of the factors. We will require the cost to be as low as possible while selecting a transmission medium. Now this diagram is really important. Categories of transmission medium. There are two types of transmission medium: guided medium and unguided medium. Guided medium in the sense they have they have that mechanism where the particular signal will be guided, and there is one situation where a particular signal won't be guided, right? So the one with guidance is known as guided media, and the one without guidance is known as unguided media. So as far as guided media is concerned, we have twisted pair cable, coaxial cable and fiber optic cable. And as far as unguided media is concerned, we have radio waves, microwaves and infrared waves. And as far as twisted pair is concerned, for better protection we have shielded twisted pair cable, and the other type is unshielded twisted pair cable. Regarding guided transmission medium, guided transmission medium uses a cabling system. Now this is where the guidance comes from. They have a cabling system. The signal cannot go out from a particular cable system. So they have a particular guidance to reach from sender to receiver that guides the data signals along a specific path. And as we have seen in the diagram, guided media consists of twisted pair, coaxial cable and fiber optic cable. Twisted pair and coaxial cable use copper conductors to send a signal from sender to receiver, whereas optical fiber uses, as the name implies, it uses light signals to transmit a data from sender to receiver. So as far as twisted pair and coaxial is concerned, they use copper wires or copper conductors to send a signal from sender to receiver, whereas optical fiber is concerned, it uses light waves to send a data from sender to receiver. So this is the example of unshielded twisted pair. As far as shielded twisted pair is concerned, it is of less protective in nature because we don't have any extra shield to protect us. So this is unshielded twisted pair. We have polyvinyl chloride jacket, and this is a foil, this is a copper wire. You must have seen this in our cabling systems. We use unshielded twisted pair cable, and this is a shielded twisted pair cable. So it is quite protective in nature because we have outer jacket for protection, then we have shield to avoid attenuation, that is loss of energy, then we have again foiled shield to protect us from current or sort of any sort of hindrances, and finally then we have twisted pair. Now again this twisted pair makes sure the signal is transmitted efficiently from sender to receiver. I hope the diagram is clear. Now this is the difference between shielded and unshielded twisted pair cables. Now there could be a scenario where they are asking you explain shielded twisted pair cable. So what you are supposed to do is you are supposed to take these 4 to 5 points and write its features and draw its diagram, and the other way could be explain unshielded twisted pair. Then you are supposed to write these 4 to 5 points as a feature or a characteristics, and the diagram which we have seen in the earlier slides, that should be drawn. I hope the point is clear how to write features or short notes and those stuff apart from difference between excuse me. So difference between unshielded and shielded is this is an ordinary telephone wire. It comes with unshielded one, and in shielded we have a metallic braid or sheet to protect us, and it is subject to EMI, that is external electromagnetic interference. In the sense loss of energy is quite more as far as unshielded is concerned, but interference is low and the signal is transmitted efficiently in shielded pair. And obviously unshielded has high EMI, that is high interference, so it has low performance, whereas in shielded due to reduction in interference it has better performance. And obviously in unshielded we don't have any extra protection, so that is less expensive, and this is more expensive, in the sense cheaper in cost and cost is more. As far as unshielded is concerned, it is easy to install and it is difficult to install, and hence it is much more flexible since it is easy to install, and hence it is inflexible or not flexible. This is the diagram of coaxial cable. So we have a protective plastic covering, and plastic covering is a bad conductor of electricity, so obviously it protects us. Then we have braided outer conductor, and then we have insulating material again to protect us from shocks or something like that, and finally we have copper wire. So the amount of protection is quite huge as far as coaxial cable is concerned. Again, in case if they are asking you explain features of coaxial cable or write short note on coaxial cable, then you are supposed to draw this diagram and you are supposed to write 4 to 5 features from the difference between that is coming ahead. Fine. So this is it regarding a comparison of guided media, right? So in case if they are asking you write short note on coaxial cable, so you are supposed to write these 4 to 5 points and you are supposed to draw the diagram. I hope the point is clear. Regarding twisted pair, it uses electrical signal for transmission. Same goes with coaxial cable, but as far as fiber optic is concerned, it uses light signal, that is optical signal for transmission. And twisted pair is affected by EMI and noise. That is a disadvantage of twisted pair. But as far as coaxial cable is concerned, due to its structure, it is less affected by EMI and noise, and due to light signals, again it is not affected by EMI and noise. Bandwidth is low as far as twisted pair is concerned. Bandwidth is moderate as far as coaxial is concerned, and bandwidth is the highest as far as fiber optic is concerned. And all of them are used for analog and digital transmissions. And since bandwidth is low for twisted pair, it supports low data rates and bandwidth is moderate for coaxial cable, hence it supports moderate data rates. But as far as fiber optic is concerned, bandwidth is so huge that it supports data rates up to 3 Gbps, and cost is very less. As far as twisted pair is concerned, cost is moderate for coaxial, and cost is high for fiber optic cable. And due to low cost, attenuation is more. Due to moderate cost, attenuation is moderate, and due to high cost, attenuation is least. Installation is easiest as far as twisted pair is concerned. Installation is easy as far as coaxial is concerned, and installation is difficult as far as fiber optic is concerned. Signal to noise ratio is less. Signal to noise ratio is moderate, and signal to noise ratio is high as far as fiber optic is concerned. Crosstalk is more, in the sense disturbance as far as signal transmission is concerned. Crosstalk is moderate, and no crosstalk as far as optical fiber is concerned. Regarding microwave transmission, that will be covered in the upcoming video. Remember students, in chapter number 2 also we'll have 2 videos. This was the concluding slide of chapter number 2 part 1. I'll soon upload chapter number 2 part 2. Till then, take care, bye.